Hello, hello, hello. Are we back? Are we back? Yes, we are. Great. Okay. Sorry I was so long. I went to eat. I went to toilet. I struggled with getting editor up for YouTube. Apparently, I have to wait until it's processed. So the previous videos are out of play for now, simply because I shared my email on them. So I need to edit it out. Great. Luckily, no one watches because damn, I'd get a lot of spam. We're at the point where I wanted to automate the process of what matrix of possibilities I could have for electron shells in terms of just formality. There's nothing special about this, but just a bit of fun, really, essentially. So if I if I just sorry for my random ticks I have. uh, in this case, it's saying that if n was defined as 1, um, basically L must be 0 because L must be n minus 1 or 0, and or between 0 and n minus 1. And then m must be uh, any number between the absolute value of L and the absolute value negated of L. So this makes sense, right? So as I put in, let me just rerun my program. A little bit pissed, by the way. If I were to put in the value kind of 2, then I think it's plausible to have an output to tell you uh, all variability if the n shell was 2 or the quantum number was 2. Size of orbit, that's it. Yeah, I have to watch out my wording. There's no hand waving here. I don't want hand waving. No, thank you very much. Okay, so let's do that. Um, Now I did these validation functions. Um, Sorry if I'm a little bit slow, but I suppose I could reuse those, because these I in this current point in time, this one and this one. Let's do that just to make them nice and evident, right? Nice and visible. Um, may I just say, I improved the quality of the OBS streamer, and I have to say that is so much easier to read this time round. Cool, that's good. I'm glad to glad to see that because it was crap before. Right, so uh, so first things first, I want to grab an array of all possible values of L, right? Alongside the M. So the output for this one will be something like a set. This would be a set in maths. Let's go for the array because we're in programming languages here. It would be something like n, and then 0 uh, all the way up to n minus 1. So there's our set or array. And then for this one, by the way, this is for L, and for M, and let me just refer back to this. So it's got each value is an array, so you've got like a little tensor here. Multi-dimensional array, as they call it. So let's think about that. Now, do we want it as a multi-dimensional array, or do we want it as an object whereby there is an array of objects with properties n, L, and m? And I think from a programmatic point of view that makes the most sense. Having said that, using that inside an ML functional programming language, I don't know if that will satisfy its requirements. However, we can have a function that you call to output the multi-dimensional array format of it. So let's do a property-based class because we are cool. So let's do that. In this case, that would be something like this. N equals value, L equals value, and M equals value. Cool. So, oh, and by the way, this is an array, so we don't be scared to have more than one. Decaf coffee. Hmm. 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 Interesting. That was a weird initial taste, a little bit odd. Uh, I poured out a full caffeinated version of my coffee first. Accidentally, I pressed the wrong button. I was like, hang on a second, this isn't right. Uh, and so that's out there now steaming away, and I'll guess I'll have it cold tomorrow morning or something. Uh, what did the finish say? Uh, finish say something about cold coffee. Can't remember what it is though. Stay pretty or something like that. Of course. Right. So let's start with L. We'll validate that the number that's being typed in is okay. And if it is okay, that's fine, but we want to do full processing after n is put in, right? So um, let's do, hmm, I sup yeah, I suppose it should be on the push of a button for now. For now, we'll think of the UI later. Okay, let's think of the UI for later. So this is post n input. We can generate a set of all possible values for L and M. Now, this probably should be a different function. I'm not so keen on multiple layered functions, or multiple purpose functions. So let's say generate all possible values for L for oh. Now we could have a function that does a whole lot, which would be cool. So let's do that. N, L, and M. Let's do that. I like that. And then we just pass in N, L, and M. And this will return a list of objects. I don't know how to do that. Is it like that? And this object is to be defined. Gosh, sorry. As a model somewhere. Let's call this. Now, that is interesting. What was my original thoughts on this? Okay, fine. That is fine. So let's do. So first official model. We will call this data, schema, structure. Well, yes, I suppose. I suppose data does infer enough about what I want to achieve here. So let's do that. And let's call this a Electron shell. What is this about again? This is about electron configuration. That's what we like that. We like that word. Electron configuration. That needs to be a .python file. Not that I remember how to declare them. Classes like that. Okay, so we'll go class electron configuration. This will be having an initialization. So we'll have an init, and this will have references to n, which is an integer, l, which is an integer, and m, which is an integer. Now it will be an array of these. No commas apparently, my apologies. And in the initialization, we should be able to pass these baddies in. So we'll have n int, l int, and m int, and we'll have to set those to do their task in the end. L equals L and self.m equals M. Done. Okay, cool. So we have an electron configuration. Let's put a little marker up here, and let's put a little reference to my topic here. So I don't know where the hell it came from. An electron configuration denotes a set of possibilities per n. Here's the thing, right? These should be optional, so let me go and see if we can do that in Python. Python optional parameters. Yeah. Okay, so it says equals, but to be honest, I mean, maybe I can do none. But then again, it's not an int, so let's always assume. Oh well, okay, a nullable int. Let's see if they got that. Python nullable int. Nullable integer data type. Pandas? No. Optional. Int equals none. Oh great, okay. That's good. So let's do that for these two. Ooh, I don't like that formatting. There you go. So what that means is if I haven't declared one, then I can calculate it. So uh, let's do that now. I think the electron configuration itself can probably house that in that logic. I probably should pull it out into a service, but we'll wait until I require that, so not to overcomplicate the models that I've got declared. And I nearly spilt that everywhere. The other funny thing about my coffee is when it was pouring on the machine, it was pouring down the edge because I'm an absolute idiot. But that's what happens when you've had 3 beers. Okay, cool. So, fine. So we're going to have a function here. Not sure what that's going to look like yet. Probably have these validations in it, but not quite yet. So I want to get an electron configuration here. So we need to define electron configuration. We'll need to import it because it's now something that is not in this file. I think that's how it works, right? Do I do import electron configuration? Nope, we don't do that. So I guess we do from models dot, let's see, models dot data dot electron data, fine. Electron configuration is the file name. Import electron configuration. Okay, got it. I always forget how that works. And here we'll have electron configuration equals an electron configuration with N, M, and L, or N, L, and M. Now that's interesting because these are kind of come out 0. Well, that's okay, I guess. Not really. Well, it'll be fine for now, so let's do that. And based on what comes into there, I should then validate if they're correct. So I do agree with myself that these should be declared inside the electron configuration. So let's move those over there. Validate L with N. Seems good. I guess this won't work. So that's fine. Let's remove. Well, let's see. Okay, let's comment this out for now, and we'll go back up to here and copy this one. So now we have our M and L. Values for N, L, and M. Ah, that doesn't sound right. That's what I want. This one here. Yeah. And we'll comment this one out as well. And now, now I need to, on the initialization of it, I should kind of define or automate or generate. And in fact, I think I already called this generate all possibilities for L and MLN. So let's do that. I like it. And this will return a list of nothing. It won't return a list. It'll return nothing. It's going to be a void. So let's do that. And I think most of this is bullshit now, so let's just go along with that. Cool. So in this case, if right, so we need to validate. We don't want to validate. We want to generate. Ah, yes. Well, this is wrong. So we do really need an electrical configuration service. These will be inside the service, and these will denote the actual entity itself. My bad. Let's go ahead and do that. So if we go to services, and we'll call something called Electron configuration service, or Electron service. Electron service for now sounds good enough, but probably not good enough. It sounds good enough, but probably isn't good enough. Let's do configuration service. Good. We'll do a class of Electron configuration service, and this will deal with all logic based on Electron configuration stuff. Okay, and this will need a, you could pass in, no, this could be like a static class. It doesn't need to be instantiated per se. So it could be just definitions, but this is kind of a hierarchical thing that I've learned from C#. So let's go for a set of functions that come from an instance of a configuration service. Right, and this will come from here. Boom. Yes. Okay. Now, if you were to pass these in, then you would need to validate with L in mind and then M in mind, base from N. We don't want to really validate stuff. We want to just generate all possibilities and then error at the end if there is no possibility at all for it. We could do that step by step by validating L first and then M. I suppose there's a reason for doing that, but maybe, okay, maybe. Let's think of that. Let's keep that in mind, sorry. So this is the end result. So maybe our service, when generating all possibilities, can return a list of electron configurations, right? Let's do that. What does this need? Typing from import list. Okay, cool, I didn't know that. And this will then return that list. Generated electron configurations. Cool, let's go with that. I like that a lot. And that will be our list of electron configuration equals whatever, right? So, do I do that? I don't know. I don't know how to do this. Do I do that? Oh, you can see I'm not a Python developer. And I can imagine it would be something like that, right? And you do electron configuration 1, 2, 3. Is that going to work? Do maybe like this? Jeez, is that it? No. Let's Google it. List of Python list. List. Where's the word list? There it is. Okay, so it's actually like that. That can't be right. What have I just seen there? That's not right at all. It's actually that. Go away now. Shoo. No code actions available. Electron configuration is correct. I don't need to declare new, right? In this constructor, make a list. Equals a list of, what is it saying here? Expected expression. View prompt. Expected expression. Great. Not sure what that means, to be absolutely honest. Electron configuration is definitely being imported here. The list was imported. I'm declaring this as type of list. Oh, look at this fucker. Silly me. Okay, right. And this is not happy because it is not returning a list of that. Generics. Sheesh. Okay, cool. Sorry, C#, C++. What can I say? What can I say? Okay, cool. Good start. Now our electrons widget needs a note of this service, so let's do that. We'll put that in the actual initialization. We'll call this the electron configuration service of that type. Good. We'll import that and we'll new it up here. Electron configuration service. There it is. And this will be referenced in the operation clicked, because when I click on the button I want to do the validation and population generation, whatever. Cool. So here we define our configuration, and then here we want to generate all possible values for n, l, and m. So we can pass in that configuration. Why not? And then, well, yeah, that's interesting, because we're passing in a configuration. We should have all possible configurations. And I just think that telling someone you need to define a configuration before generating a configuration seems a little bit strange. So let's take away the notion of this pre-declaration and let's pass that in there. Awesome. Let's do that instead then. And this will be an array, a list of Electron configurations without the service. Yes. And this is going to be local, so that's all good. This is not helpful. That is helpful. So now we're generating all possible values, and then we need some kind of stringify function. So even though we generate the list, we need a service that gives us an output for the list. Cool. Let's do that after. So now we're in here, we have our new fake list. Well, let's start generating real values. So we know that L must be less than n minus 1. So that means that we need to do a loop. Do a loop to populate all possible values from L to n minus 1. And that loop will look a little bit like, God forbid I actually understand how to do loops in Python. For L is, so it's from 0 to n minus 1, so it's going to be from I equals 0. Is it that? I is less than n minus 1, I plus plus, boom. Clearly not how you do them, so let's go look it up. Python for loop. Eggs and fruits. Yeah, that's fine. What do we want? Python 4. There must be a way of doing it. Oh yes, because you get Python ranges, don't you? Right, so slightly different, I think. There it is, range 0, that's the one. For x in range, you have to define an enumerator for it to work upon. That's fine, that makes sense. So it's for x in range 0 to n minus or 1. Good. That is that. Now n, they all pass in as integers, that's fine. And so this will give us an array. Let's do that. Possible values for L is going to be a list of integers, and let's see, that is going to be insert or add. Append, I believe it's append. X. Yes. Now that is going to give us all L's, and this will give us all. Let's do this here. Do a loop to populate all possible values from negative L to positive L to L, and so this will be an negative absolute L to an absolute L. Yes, and that will be all possible values for M. We'll append that, and then each one of those is per n. Let's go back to our little diagram here. All the n's are 2 because that's the initial number that cascades down onto the L and M conditional values. So let me just double check. It is great. I was just double checking the stream's working correctly. Okay, cool. So that's done. Now I just need to concatenate the values into one list of electron configurations. Thus, rather than having that, I should do a loop around all possible L's, which will also define all possible M's in terms of quantity of values, and then for each one I'll just populate the entire configuration for that. So let's do for X in yes. Well, really though, really I want to have a range because otherwise that's confusing. So let's just do that. And can we do a length? Can we do a number? Can we do an amount? Then here we go. Type ahead. LEN. What's it saying? Get length of array in Python. And great. That's exactly what I want. So that's going to be for possible L. And for each one of those, I'm going to do a new array of generated electrical configurations. So I've already got one up here. So let's start using that. That'll be an append. It'll be n. No, it'll be that electron configuration is going to be populated with the following values. Oh, thank you for raising my okay, and that's fine, but I need to get the index of this rather than the value from this range. I guess that will be correct because yes, that is indeed correct. So let's do that. Index will be fine, and it'll be possible values for L, I, and possible values for M, I. Yes. No. Well, maybe. I foresee problems with this. I think there's a bit more to this because for each I, there is a larger set of values. For each L, there is a larger set of values for M. So if I go back to the diagram that they've prepared for us, you have 3 1s and 4 2s, but 3 1s, and these have a larger range. It's not this, it's actually all defined in the already calculated arrays that I've got. So first of all, I need to iterate around the L's, so let's just do that instead. And rather than in an in range, I'm going to do current L. Yes. And then inside that, I need another for loop. Essentially, it's going to be for possible value for current M in possible values for M. Then we now have our construction of a loop, and the current L will be passed in fine, and the current M will be passed in fine. I think that does it. Can't see any problems with this yet. We shall see on the output. Now, we now have this generated electron configuration. The service should not have an idea of what that is, but it should. Let's just get rid of these dudes for now. I don't know if they're really that interesting. Well, maybe they are. But let me actually just comment those dudes out. we want a way of outputting this into a string. So output or convert, stringify, make electron or readify readify electron configuration. I like it. And this will take a list of electron configurations, and we'll call this electron configurations. One day I'll be able to type. And we will loop through current in electron configurations, and we will stringify it. So let's just do a string output string of type string equals nothing, and then we will output string plus equals something like that. In fact, that should be at the beginning of that. That should be at the end of that. And in the middle, we shall do a little sorcery of n l and n. And let's get that in. So n, l, and m. Now, where are those values coming from? They're coming from the current dot. Now I'm hoping they're going to be in there, because current is a list of electron configurations, so current should know that it's an electron configuration, so that should be fine. Where is the type ahead? Why am I getting all of these other options? There they are. Okay, we are good. Let's go with that. Awesome. Readify electron configuration. So let's just make note of that. This is converts an array of electron configurations into a readable string. Awesome. And then we need to return this as a string, and in fact that would just be the output string plus equals the ending string, and we'll get rid of that sign there. In fact, why not just hardcode the whole bloody thing like so, and just make that an empty string at the beginning? Because why not? Less confusion, I think. Good. So that sounds about right. Let's get an RNN in there for a return carriage. Excuse me. And there as well, and at the end of each one of these, and we'll have a comma as well. Good. I think that's that. So now we go into here, and we've got our little service, and we're going to generate that shit, and then we'll go back to the service, and we will generate, no, we'll readify the electron configurations, which should be that, and that should be in there, and that should give me a string output string equals, and then we'll pass that into the set output message self dot output message, and we'll put that into the output string, and we will comment the rest out for now. I think that is it. Let's see what happens. It says invalid syntax, electrons widget Python line 64. Now we're in here, so if I go to line 64, it does not like that. Interesting. I'm guessing because I never really defined anything there. And in fact, I can just delete that anyway. Let's just do that. And let's continue. Here we go. So, if I put in a 5, press that. Great. But it did not run my sexy new code. So, it's defined shell letters. It has not decided to do anything else. It's set the output message great. But here I should be getting something relatively interesting, and I'm not. And that's because the local variable possible values for L referenced before assignment. Okay, so here, if I press my button, okay, it's that one, sorry, press it, and I step into that. Now, possible values for L, I'm guessing, yeah, because, I see, because N here is 5, so that should run over that, and so I should get, oh, there you go, I should get there, but I do not. Local variable possible values for L referenced before assignment. Okay, I see, I see. I think maybe I need to do that, and I suppose that makes some sense, so let's try that now. And put in our 5, and we'll put in that instead. And yes, I guess I want to see the output maybe later though, so let's go step in. Step over, we go along here, we go to the next part, we've got our L's 0 to 4, I think that's what we put in. We put in 5, that's n minus 1, that's great. And so we should get to here, and we have our possible M's are not looking good. And our L is 0, that's Y. So it's for each M I need to populate that, of course, that makes sense. Let's do that. So I need to go through all of these for current L in. I see, I've already done that. Possible values for L. This is wrong. I see. So hang on a second. Possible values for L, and we're going round n minus 1. That's great. Current n, current L. This should be, and this will give us a range, a correct range, and that's per n. And this should give us a range for current M. Cool. But these L's need to be coming from this, so I need to do it for each L this is simple stuff. I just need to have a think about it. Um, okay, yes. This is simple. I must uh, think, James. I must think. Absolutely must think. Yeah, I need to iterate through these values, and for every value of L, I have a possible n values for M. That means this must be a loop inside the L loop because L generates possibilities, but those possibilities are n possibilities. I see. Yes. So actually I need this to be a loop from well, let's think about this. Let me just draw a picture. White screen. Why must you be so white? How do I invert that screen? That is crazy. Flip, resize. It's so white. How do I invert the properties? Image properties, sets this background. Black and white. No. I swear I used to just right click. Oh, there we go. Oh, I see. Oh, okay. Right. Fair enough. Didn't know that. You have to have this little selection thing to about the color. Cool. Why is this white as well? I mean, I've set this theme as dark. Come on. Anywho, let's go for a nice calming orange. If I were to have, you could tell it's late. This is a very simple problem, I promise you, and I'm fine with this usually. Yeah, okay, so uh, I'm gonna have a list of I'm gonna have an n value, n equals a list of L values, so L, L, L. So I need to do a loop around this L to get my, and we'll just go into subdivision here. This would be M, M, well, not totally mathematical there. Let's go there. M, 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 dot, 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 etc. Wow. So then this will have its own, this will have its own. So it's going to be a loop around L for M's, and for each time I loop around the L, I must output 1, output 2, output 3. So actually in my loop of L, do a loop to populate all possible values from L to n minus 1. In that whole entire range, I want to almost just iterate down into the m's as well. Let's do that. Let's just stop confusing myself here. So I'm looping over the n's, and inside here I'm doing this calculation. Current L, there it is. Yes, yes, yes. I like it, I like it, I like it. And then for in there, I'm going to do that. A 3 depth array. Whoo boy. Yeah, nice, I like it. So this is going to be the current current L. This would be current M. I think actually maybe that's just enough. Yes, I think that might be enough, and this ends up being like so. I think it will end up like that, and this is no longer required. This is no longer required, and this comes from current M. Yes, I need that calculation though. This absolute one. Well, that's it, isn't it? So it's for the current L is m minus 1. I don't think I need that. And so now we have n defined as we pass it in. L is being generated from n minus 1, and for every single time that happens, going back to our little diagram, wow, that's a great diagram. For every time that happens, I've got a subset of m, and the m comes from the current m, which is a negative absolute value of the current L to the absolute value of the current L. This I can produce an electron configuration for, and we can return a thingy-majiggy bobby. I think that is about it. Let's see what happens. 5, push button, where do we get to? Step into, step over. Let's take a gamble here. What do we got? Ooh, lots of stuff. That looks good. 1, so 5 is my n. L can be 1, but it should also have 0 in there. Yeah, it hasn't done 0. Not a big deal. But hey, check everything else out. That is working. 0, 1, 0, 1, 2 for M. Length 12. So I think that's about right. Just I'm missing my L0. Why? In a range including, I'm guessing this will be in the specs here. 0, 1, and 2. Well, why the fuck is that not coming through as 0? Current L will be 0 at the beginning, right? Negative 0 to 0 will not give us an output, that's why. I see. Well, okay. The problem is negative 0 to 0 is nothing, so it won't actually do that iteration. Now I could add one, and then I need to do minus 1 absolute. That's fair enough. We can do that. But that is about it. So I think we've got our output there. That's good. Moving on to the next part, I guess. I'm just going to do a blood test quickly. I did quite a big injection because of a blood test I had. Basically, I was thinking, you know what, if I go low, I'll just be able to eat more. So that's why I did it. And I think I probably am going a bit low. I might take a little break. See if the other videos are ready for processing, and I might carry on a little bit later, or might go to sleep. We'll see. Might play a bit of Far Cry. Nope. Blood sugars are fine, so I guess they're coming down now. I'm just, I guess, a bit tired. Let's be Ron then. I definitely shouldn't have any more injection, that's for sure. Okay, cool. Let's do that. And so, oh, my mouse has gone randomly fast. What did I just do? That's what I just said. Okay, cool. I think then if I add one, it's a range from 0 or minus 0 to 1, the index will be 0, so I need to just plus 1 here. Let's just see what happens. Anyway, let's go 5, push the button, see what comes out. I'm sure it's all fine. What did we get? Nothing. But that might be an issue. Here we go. So yeah, it is that. It says can only concatenate string, not int. So let's just force these to strings. It's nice. I like that error. It's better than JavaScript. It's just like, yeah, this is all fine, and it starts like adding weird outcomes because it's decided what's a string or not what's a string. What do we have now? Alright, and I think, yep, that looks busy. What does busy do? Gives us a big old array. And what do we have here? A super unreadable array. Sheesh, someone's made a mistake. N, L, there it is. M. I suppose maybe it'd be a little bit easier if I also did that and indented that. Something like that. Of course, what I could do is run it through a JSON parser or something that will do it for me, but hey, living on the edge. Living on the edge. Let's rerun this. I think we're good now. Right. Yeah, that's why that doesn't look good. But why on earth has that happened? That is because I have clearly not given it the right instructions here. Is it and no break space? I don't know. Does that work? See if that works. I don't know. I don't know what it likes. It doesn't like that, that's for sure. Maybe it's just backspace S. What does that look like? I thought spaces were just picked up, but hey, what do I know? Nope. Okay. Let's add space in Python string. Yeah, I think it does. I think I am being a noob. Let me take away those and add those spaces back. Let's just see if I didn't completely noobify what I was doing. Yeah, that is not what I'm expecting to see. Now, here's our first one, and it's got the spacing there. Then we put our string in, and it's got an enter, and it's got a few spaces here. So that should work the same. Ah! Of course, it's not 4, it's 8 in. That's why that doesn't look good. And then that goes on a new line, and that would be just that. Yeah, we need to sort this out, but it's fine for now. It's fine for now. At least I can see what's happening, right? So good, like it. So we've put in 5, so there should be an L0. There should be a 1 with a negative 1 for the L, a 0 and a 1. There should be an L2 with a negative 2, a negative 1, a 0, a 1, a 2, up to, oh no, that's not what the doctor ordered. Where did that go wrong? Our first one's looking sweet. Our opening bracket for the next line needs to be in. Okay, let's put that there instead and put that at the end. That seems fine. I'm not sure why I didn't get the 4s there. That looks better at least. So here we got for n5, it must be n minus 1. We haven't gone to 4. That is because of our little addition, I think. In the service, we are doing we're doing n, so we got our 5. We're doing 3, which is n minus 1, but we are doing it 0 to n minus 1. So if I did a 5, it should be 4, it should be 0, but it's going to do 0. And L0 is something, but it needs to just be n. So let's put a +1 here. I think because I want to make clear that we have to go one more for the iteration. We'll figure that out later, but I think that was that problem at least. So now we start at 0, but we should get to 4. We do. And m3, 2, 1, 0, minus 2, 4. Great. We've got it. All of them. Everything we needed. Now to neaten these up. I really don't like this happening. Let's try that. A bit more compressed, yes. Let's get rid of that. We could just put a space in there. Ah, visual stuff. Gotta love it. And we don't need those massive spaces now, so we just need that. Whoa. That should do that job. What else do we need? Nice. Now, if it's a negative, there is an additional space. So that's annoying. Let us change that. And these initial arrays are not so helpful. Now what do we have in their description? We don't. Okay, great. Yeah, so let's not do an array of arrays. Let's just output the string. If you're in agreement, say aye. Good. Let's try it now. Okay, cool. Well, that's looking alright. We can do a little if statement in here for the negation to kind of align them all. I mean, let's do that. Why not, right? The m is the only one that goes in negative, so let us just do a little check here, and we'll say if is less than 0, m string is a string, and it's going to equal, it's going to equal empty. If it's less than 0, do that. Nope. If it's greater than or equal to, then we need to do a space, and then we add the current m. Otherwise, we'll just do the current M. Wonderful. That is exactly what we want there. M string goes into here. Okay, I think that should tighten everything up now. Not quite. If M string, if current.m is greater than 0, then do a space. I mean, that's right. Oh, yeah, equals that. Cool. It's always something stupid. Oh look, that looks good. Let's just double check our stuff here. So we've got, for n5, we've got 0 to 4. 0 should have 0. Yes, because m must be all ranges from 0, so that makes sense. Pretty much what they're saying here. And then L must be 1 for 5 and 4. I mean, yeah, that's pretty much it. Now what we could do is just add a little separation here. For each iteration of this, no, for each iteration for this, we should add, okay, so every single time, yeah, every single time L goes up or changes, then we want an extra enter. But think, yeah, let's just do that. Make things clear. Let's just do that. Really get a figure in my head of how this is all working. So we're going to say if the current M is greater than 0, that's great. And if the current, okay, so we need a last L is going to be an integer. That's going to be 0. And then last L will be defined straight away current.L, and let's see if I can do that again. If so, last L if last L is not does not equal current L, not equal. Can I do that? Not equal. Not. If last L is not current L, then can I do is not? Cool. If last L is not current.L, then output string plus plus equals a \r and a \n. Yes, I think that's enough to separate that out. Although we'll have on the initial condition, so we'll need to is not and last L is not 0. And then we'll need to add some comments after this as well, because it's going to be so confusing. Well, interesting. Let me just double check that even gets in there. It doesn't. Why does it not get in there? Last L is 0. Okay, it's 0. This is 1. Ah, yes, well, that's clear as bloody day, because it needs to go after that. And that might not solve everything, but I think that's at least closer. Yes, I think that's going to work actually. Good, 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 good. And the 0 can happen as well, that's great. I wasn't sure about that after I just changed that last part. That is good news. So there you go. Not bad. So this shows all configurations fine. Of electrons. I suppose what we could do. Yeah, no, that's fine. I think we'll have some problems later on with like formalization of this stuff. So, um, what I mean to say is it's a little bit messy. It's a little bit manual the way I'm iterating over things. You know, checking if um, L is greater than the last L is not feeling ideal, or at least in its current form. And I think it's important to really get in the code when those changes occur if I'm going to iterate over an array of them. So I should really have like a like an object that knows more about itself that I can then iterate over. That's important because I'm supposing that for every single iteration of this, I need to act upon it. Let's say to draw, uh, calculate, apply logic, etc., etc. But for now, that's fine, I think. Um, the premise is there, it's working. Happy days, I guess. Last one I suppose I can remove is the array simple because it's kind of irrelevant here. So let's just do that as well. And in fact, it really means that I can remove all spacing. Um, Now, how do they don't do that either. So they just put nice spacing before it. Yes, and okay. Well, that's going to be fine, isn't it, really? The rest is just absolute bullshit. I don't need to worry about it. Yeah, that's fine. Good. Good little progress here. How long have I been going? Hard to tell. Oh, okay, 1:13, so about 2 hours in total. That's fine. That's a good little day's work, especially on a holiday day. Um, where does this go? So there is only one orbital in the 2s subshell, but there are 3 orbitals in the 2p subshell because there are 3 directions in which a p orbital can point. One of these orbitals is oriented along the x-axis, another along the y-axis, and the third along the z-axis of a coordinate system. As shown in the figure below, these orbitals are therefore known as the 2px, 2py, and 2pz orbitals. Good. The shapes of these are feeling arbitrary here, but I remember back up here that it's not so much like that. So yeah, L equals 0, it's got shape, so I need to define here what type of shape they are as well. Let's see. Yeah, it kind of just continues on a route of cool stuff that's worth remembering, so I guess I'll just plow through this even more. So the real main goal is to just get an understanding of this stuff because I need to start to put my head or face thoroughly into the equations, because next step, quite frankly, is to put them into Unreal Engine and simulate them. That's going to need what I'll do is I'll randomly select any one of the possible positions generated and simulate that horizon of events or horizons of positions, and then I can start putting machine learning in, because so I was having a think about this. This is a good way to end the video, actually. I was having to think about this. If I have, I mean, this is not what this means, but let's just take this. No, let's not do that. So if I show you, here's, whoa, that's big. Here's an atom. Let's try that again. Here's an atom, and here's electron 1 and 2. Atom 1, electron 1, 1, electron 1, 2, where the first number is related to the first atom. And let's say this is atom 2, electron 2, 1, electron, try that again, electron 2, 2, 2. Cool. Now, you may be thinking, I guess, probably not, but you may be thinking that, well, what is the force occurring along this proton and electron repulsion, and what is occurring along this attraction? What is the, so this is attraction, right? This is attraction. This is positive and negative, or positive and negative. But and then you've got the repulsion, right? So something like this, and this is going to be negative and negative. And of course we've got this over here as well. Negative and negative. And then we got this over here, right? Negative and negative. And then we've got this here, coming together, attraction, negative and positive, and then this here, say this is the left, positive and negative, right? That is two atoms considering the attraction between one electron and all possible electron configurations, right? So let's imagine that as a table. We then have, so you'll see why I'm laughing. We have atom 1, electron 1, 1, and we have electron 1, 1 has an attraction to A1. So electron 1, 1 has an attraction to A1. Oh, well, okay, that's it. That table's fine. So it's an attraction, right? And then we've got, let's do it the other way around. So we've got for electron 1, 1, we have an attraction to A1. Okay? And then we got electron 1 has an attraction to A2. And electron 1 has a repulsion to E2 1, and electron 1 has a repulsion to E2 2, and electron 1 has a repulsion to electron E1 2. So that, in some hypothetical sense, is all interactions for just one of the electrons on one atom. Don't get me wrong, if these are hydrogen atoms, great. But I don't think all proteins are made of hydrogen atoms. So this is going to explode into possibilities, right? And that's a figurative, explicit condition of I know precisely on this frame of time where the positions of all those electrons are and the atoms' protons, right? I say A1, A2, that should have been P1, P2, my apologies. But then you've got, which I forgot, let me just do this properly, right? So this should be, not that. Oh dear. Oh, that's interesting. Didn't know you could do behind it. So let me just do this properly. This should really be P2, P1, and these I'll have to go and modify over here as well. My apologies. Whoa, I have no idea how this program works. Oh yeah, here we go. Because I just don't want to be confusing with it. P1 and P2. Okay. Here's the thing. We've also got things like, and I don't know how far this goes, but E equals mc squared, right? So this is not equals mc squared. Well, in a way it is, but it's just simply gravity, essentially. The gravity from the mass of the neutron. So you're going to have an attraction to, so E11, E12, E21, and E22 will all have attractions to their neutrons, right? So we've at least got one more in here, or two more, perhaps, depending on how close they are. So E1 will have an attraction to the gravity, what is a function of E of P1, sorry, and E11 will have an attraction, albeit small, maybe, to the gravitational function of P2. Okay, so back to my laughing. Very rough sketch of all possibilities of absolute known positions of electrons. Here's the thing, because of the X, I don't know, I've forgotten the uncertainty principle. Whatever this angular momentum is, I can't remember the symbol for it, but let's call this P. I think it is P. So this is the Heisenberg uncertainty principle. Or just do UP, uncertainty principle, right? This chappy says the more precise you are with the position, the less precise you are with the momentum, and that gives us clues on where the next position will be. And so if we try to be more predictable or more accurate about the position, the momentum, then we have less accuracy on the position, and that's because these are scalars of each other. Every single fluctuation that happens in one of these will alter the other one, and this must always be equal to greater than or equal to, I think it is actually, Planck's constant, the amount of energy for emission of electron, I think, divided by 2. I think that's right. I think this might even be, you know what, I just can't remember, maybe 2 pi or something like that. Let's just get it right. So Heisenberg uncertainty principle equation, I can't remember it precisely, so 4 pi, okay, and these are changes in Planck's constant pi. Okay, so that's wrong. So it should be 4 pi. Okay, cool. Anyway, regardless, still a fuckery of the highest order, which means all of these interactions are going to have a probability based on them. So if there's an infinite amount of possible positions, you know, given this is like an infinite amount of space that we're working in terms of how much you want to change each frame of measurement, then we have a lot of calculations to play out. So we need to cleverly decide which ones are really going to alter the outcome of the protein fold and thus its function, so we can eradicate some of these choices. Let's imagine, just for sake's sake, that this actually ends up equaling 7 to the power of, I mean, it could be anything, 7 to the power of n, right? 7 times 10 to the power of n, okay? Let's imagine something like that. Well, we need to say, of how many of those do we actually give a shit about? This is a value from the function of machine learning. So when we start to understand the physics and get some simulations running on specific locations and their momentum, we can run a few frames over positional or explicit positions. Once we've done that, then we need to start taking into account that there is this possible amount of situations for each and every electron in a set of atoms on a protein. This is not computational. This is not computationally possible at this moment in time. So we'll take a few shortcuts, right? Now, those shortcuts will be, yeah, well, which ones, where the protein folds, does that really make a difference to the output, the function of the protein? Because if it doesn't, don't care, right? So we can just kind of group up. We can group up function of protein, right? Func of protein. And then we need the second group, which is going to be given a state, what are all the currently measured states in actual experiment that we find, and we can compare that training data. So we'll go all experimental data and its given fold and its or and its uh, um, resultant fold, right? Okay, that in itself probably knocks quite a lot of the um, amounts down, and then we'll start to think about other things that we can do, i.e., you know, every frame, do we need to calculate all electrons and their links to attractions and repulsions, or can we say, well, after a given time, or after a given distance, the effects are so small that they probably don't have a large sway on the output of the protein's fold. So distance um, distance still relevant kind of thing. So that's the kind of problems we've got to solve. These are problems that AlphaFold, I believe, have solved or are solving. And I ain't in no competition with AlphaFold, that's for sure. I'm going to be using theirs as soon as I start to understand this. I'll be looking at their code and trying to use it. But I must understand this first. Given all that, I mean, that's quite a journey ahead. I hope it's not too far ahead, but it's a journey ahead. And after that, we need to start to consider um, how DNA uh, how DNA directly corresponds to configuration and ergo fold. So that is the goal, I think. And at that point, we can start to think about the next part, because I'm thinking nervous system is a good way in to tackle what I want to achieve as a human being. But I also see flaws in my original plans given the more I find out. Anyway, that's where we're going, that's where we're heading. Um, yeah, happy with that summary. We'll continue soon. Um, keep loving, keep learning, and speak to you soon.